Our seventh track is called well spacing optimization. So this is Spindletop, Texas, over 100 years ago. So obviously not optimized here in this case. So this is a 7 plug and perf well pad in an oil reservoir with complex multi-phase fluid behavior. So obviously that lends itself to numerical modeling. And what you're going to see is some really amazing developments from one company that is a vendor of rate transient analysis and what they've done to enhance their numerical modeling capabilities. In this study, RTA is used to calculate 30-year EURs and recovery factors as a function of well spacing. And I did this for a dear friend of mine. And he worked at a company, he just started there, and he was the manager of the asset team. And he wanted to communicate what reserves could look like as we downspace or space wells far apart, and also get a sense for recovery factor. Especially recovery factor when you're looking at PUD locations and you just apply recovery factors to volumetrics. So this is I'm about to show you what the results look like. Here we go. My buddy said that the economics dictated at this company that he needed to see 500,000 barrels per well for a 30-year EUR on each of these wells. How many wells can I drill given that objective function? So we took this recently developed numerical modeling, which is super slick and fast, and we created what would have taken us a month or so to create results in a matter of a few days. And that would be a very painful month, if not longer. And here you're seeing every little dot on that map is a different numerical simulation run. So what we did is, for this particular, well, you're seeing all 7 wells on the pad here. And you can see that for a different number of wells per section, that's really just different drainage areas, different well spacing scenarios. So that's why you're seeing some dots that are between 7 and 8 or 8 or 9, because it's really just a drainage area. And what you're seeing is eventually you get so heavily downspaced, your wells are so close together, say 8 wells per section, or that's what, 80 acres per well, that you're seeing that the EURs per well go down. Overall recovery in a section goes up, so maybe it's not presented in the way that you would think. But on a per well basis, of course, you start getting into competing drainage between wells when the wells are too tightly spaced. So to answer his question, 6 wells per section is the point where your average is about 500,000 barrels, and you start going lower than that. But he also said, our objective is to get at least a 13% recovery factor out of this field. How many wells per section do I need to answer that question? Well, that's a different number. That's 7 wells per section as an average. So just taking those forecasts and relating them to the volume they're assigned to drain for recovery factor, at 6 wells per section, we're seeing 11.2% recovery factor as an average. And if we want 13, we need 7 wells per section. So this is how we can do these exercises fairly quickly. And again, this would have taken us forever if we had to do this a couple years ago.